Today I'm going to tell you about partial fraction decomposition. When you decompose into partial fractions, you are taking a rational expression and you're writing it as the sum of two or more simple rational expressions. So in this case, x plus 7 over x squared minus x minus 6 is equal to 2 over x minus 3 plus negative 1 over x plus 2. And there's a nice procedure that will allow us to do this. So the first step to decomposing a rational expression is to divide them out if it's improper using long division. So I want you to pause the video and I want you to divide these two expressions. Here is the answer. Almost here's the answer. Here we go. Here is what you should have gotten. So when you did your long division, you should have found that you got x, and then you would have had a remainder of 5x squared plus 20x plus 6. And now the degree of the numerator of this rational expression is less than the degree of the denominator of the rational expression. So we can go on and decompose. So the next step is that we want to factor the denominator. So I want you to again pause the video and I want you to factor this denominator. Ready? Go. And oops. And this is what you should have gotten. Your denominator should have factored as x times the quantity x plus 1 squared. So you keep factoring till it's prime. Sometimes you might have a squared factor that is prime, and if so, you really can't do anything about that. You just leave it as it is. Now, once it's factored, you will be able to take that rational expression and rewrite it as the sum of fractions over each factor. So if your factors are linear, you will have a constant over each linear factor, like so. However, if a factor is a quadratic that is prime, you are going to end up with a numerator that is linear. So this is how it would look. And I'm going to show you two examples, one where the factors are all linear and one where it's quadratic. So the next step is that we are going to just work with this part of it. Of course, we're going to remember that the x is there, but we're going to just work with that rational expression. So I am going to write 5x squared plus 20x plus 6 over x times the quantity x plus 1 squared as a over x plus b over x plus 1 plus c over x plus 1 squared. And this is what you need to do when you have a factor that is squared, or even to a higher power. You would write first x plus 1, then it'd be x plus 1 squared. If it was to the third power, you'd have one fraction that is over x plus 1, you'd have another over x plus 1 squared, and you'd have another over x plus 1 cubed, and so on. So right now what we need to do is try to solve for a, b, and c. And the reason that this is in the section on systems is it's going to require a system sometimes. So I am going to multiply my whole equation through by x times the quantity x plus 1 squared. And when that happens, I get 5x squared plus 20x plus 6 is equal to a times the quantity x plus 1 squared plus bx times x plus 1 plus cx. Now, I am going to multiply this out, and so that I can figure out what coefficient should be equal to 5. So when I find my x squared term over here, it's going to be, the coefficient should be 5. When I find my x term over there, it should be 20, and the constant should be 6. So let's multiply it out. So I'm going to get a times the quantity x squared plus 2x plus 1 plus b x squared plus bx plus cx. And now I'm going to combine my like terms. Well, not quite yet. I'm going to distribute my a. So I have ax squared plus 2ax plus a plus bx squared plus bx plus cx. So now combine like terms. So I have how many x squareds? I have a plus b of them. And I'm going to cross off as I go along. And I have x's. Let's see, how many do I have? I have 2a plus b plus c. Cross those off as I go along. Don't want to forget anything. And that's times x. And then finally, a. And now what's nice is I can figure out that a must be 6 because that is my constant. 2a plus b plus c must be 20. And then finally, a plus b must be 5. So let's write this out. And this is actually going to be a pretty simple system to solve. So a plus b must be 5. 2a plus bc, no, plus b plus c must be 20. And then finally, a has to be 6, which is pretty nice because as soon as I know that a is 6, I know that b is -1. And I then can find out what c is by substituting into this equation. So 2 times a, which is 6, plus a -1 plus c is equal to 20. So that would be 12 minus 1, which would be 11 plus c is equal to 20. Subtract 11 from both sides, and I should get c is equal to 9. So now once this happens, I can just rewrite my whole rational expression using these real numbers as so. So remember, you can't forget about this x. It turns out to be x plus 6 over x plus a -1 over x plus 1 plus 9 over x plus 1 quantity squared. Let me just verify here. Yep, that's what I had for A, B, and C. Very nice. So there is our partial fraction decomposition. Now, I'd like to try one where the factors do not turn out to be linear. So here's our next one. Step 1 is to divide it if it's improper. In this case, the degree of my numerator is less than the degree of my denominator, so it is a proper fraction, and I don't need to worry about step 1. The next step is to factor the denominator. So go ahead and factor it, press pause on the video, and then check back. Here is the answer you should have gotten, and you'll notice that this factor here, x squared plus 4, is prime. You cannot factor the sum of squares. So our next step is to write this as a partial fraction. And we've factored the denominator, so again, the next step is to write it out like so. Let's see, let's move this over. And this is going to be equal to a over x plus b x plus c over x squared plus 4. Notice, since this is not linear, I have to have my numerator be bx plus c. Now I am ready to solve for a, b, and c. So we are going to multiply this whole thing through by x times the quantity x squared plus 4, and when you do that, you get 3x squared plus 4x plus 4 is equal to a times x squared plus 4 plus bx plus c times x. So we're going to multiply through, and then again we're going to be able to equate our coefficients with the proper expressions. So we will multiply through by a and get ax squared plus 4a plus bx squared plus cx. Now, I know by combining like terms, I have a plus b times x squared, cross off as I go along, plus cx, cross off again, plus 4a. I know that a plus b has to be 3. I know that c has to be 4, which is pretty nice. And I know that 4a must be 4. So let's write that out. A plus b is equal to 3. C is equal to 4. And 4a is equal to 4. Nice system of equations, nice and easy one to solve. So I know that 4a is equal to 4, therefore a must be equal to 1. I can substitute into my top equation and get 1 plus b is equal to 3, so therefore b must be equal to 2. And finally, I know already that c is equal to 4. My final step is writing my rational expression as the sum of rational expressions, and here is what it should look like. Not so bad, right? Okay, so now that you've seen these two examples, I want you to begin working on your homework. Hopefully I will see you tomorrow.